This is lab 4. I'm Daniela. In lab 4, we are going to analyze the motion of oscillations with a spring and an object hanging off the end using tracker. The goal of this lab is to compare the predicted motion and the observed motion of the mass and plot the energy change that I computed in the model. So we are going to look at tracker. So this is the motion. So I use the X and the Y points. I put that into an Excel spreadsheet and converted it into a CSV file so I could use that in my Glow script. So the energy principle, it states the change in energy is equal to the change in kinetic energy plus the change in spring plus the change in gravity is all equal to 0. When the change in energy is 0, there is no change in energy of the system with the surroundings and no external forces acting on the system. That means that the energy is conserved. So we're going to look at the different parts of the equation. Kinetic energy is equal to 1/2 times the mass times velocity squared. The change in spring is equal to 1/2 times the spring constant times s squared. We have the change in g, which is equal to mass times gravity times height. So here's some of the information of the lab. So the mass of the object on the end of the spring was equal to 0.402 kilograms. The spring constant is equal to 6.83 newtons per meter. The relaxed length of the spring is equal to 0.13 meters. Gravity is equal to 9.8 meters over second squared. And so this is the initial position that we got from our first point in the tracker. And the initial velocity is 0 since it is coming from stop. So from here we're going to look at the code. Here is the code. So I inserted the mass of the ball. I put in the initial position, the initial velocity, and the gravity, the spring constant, the relaxed length of the spring. And from here, I kind of just put in the different data for calculating the L hat, and the S. And then I also did the kinetic energy, the gravity, the spring, and the overall energy from the equations that we previously looked at in the energy principle slide. And from there, to run this program, I have to choose the file, which is the CSV file that we got from Tracker. And we see the oscillations with delta energy, delta spring, delta gravity, and delta kinetic energy. So what does this mean? For your model, is energy principle satisfied? The energy principle is satisfied because the energies all add up to 0. That is why the energy line was straight, which the equation that we saw, it was equal to 0. And the energy line is equal to 0 because it is a straight line. So what does it mean, part 2? Using the data I obtained from Tracker, I estimated the period of oscillation from the X position data and from the Y position data. And in order to do that, I calculated the different peaks and divided by the time. And so I got X is equal to 1.23 seconds and Y is equal to 1.42 seconds. The periods should be the same, but they're slightly different, which could be due to human error. Thank you.